Winter in California. For water managers and reservoir operators, it's a time of important and sometimes short-fused decisions regarding water storage and releases. Wet Pacific storms bring the rain and snow that are vital to the health and economy of California. But if it's too much, the precipitation can trigger floods and landslides and cause reservoirs to rise beyond safe levels. The most significant precipitation comes with atmospheric rivers, long and relatively narrow corridors of concentrated water vapor moving low in the atmosphere.
An atmospheric river is essentially a river in the sky, but it's a river of water vapor rather than a liquid river like on land. An average atmospheric river moves about the equivalent of 25 Mississippi rivers worth of water at any given time. They're moving like 90 to 95% of all the water vapor. So they literally function as rivers in the sky.
These systems approach California from the Pacific Ocean, and as they interact with California's mountainous terrain, they typically produce precipitation. Pineapple Express is a term that was popularized in reference to one particular type of atmospheric river that stretches from the Hawaiian Islands to the U.S. West Coast. We refer to all forms of atmospheric rivers as ARs. ARs occur around the world at all times of the year, but in California, they're most common in the winter. They are also responsible for a large proportion of the precipitation in California. And most of that occurs when the frequency of these events peaks in November through April. There are winters when multiple ARs result in ample snowpack and water supply throughout the year. In other years, a lack of winter ARs can lead to serious water shortages and drought.
Atmospheric rivers drive floods and droughts in our region. So for us as water managers, being able to understand and being able to forecast atmospheric river events is essential in us operating our facilities in a safe and reliable manner.
On February 12, 2019, water levels in most major reservoirs around the state were near normal due to beneficial January precipitation provided by ARs. Another AR would help keep water supplies at desirable levels. Water managers were faced with the challenge of managing their water resources in the face of an oncoming storm.
Atmospheric rivers are the primary driver of extremes in water in the West, and hence it's been a major focus of our center's development.
The CW3E site from the Center for Western Weather and Water Extremes at Scripps Institution of Oceanography, UC San Diego, provides publicly available forecasting resources specifically for ARs. Moisture forecasts are quantified with a measure called IVT, Integrated Vapor Transport. IVT values can range from 0 to over 1,000. Atmospheric rivers are often defined by an IVT value greater than 250. A key consideration for understanding an AR is where, when, and for how long will specific IVT moisture thresholds be met. The AR Landfall Tool on this site offers helpful details about the probability, location, timing, and duration of ARs.
The Atmospheric River Landfall Tool helps the water manager answer a very basic question, which is what is the likelihood that a significant storm will be arriving in the basin that I am managing?
Here, the AR Landfall Tool shows us the forecast time period starting with February 12, 2019 for landfall locations along the West Coast. Colors show when there was the probability of meeting the chosen moisture threshold. In this case, the threshold was an IVT of 250. The forecast for far southern California showed a long period from February 14th to 16th, with more than an 85% chance for an IVT exceeding 250. The bars in this tool indicate the duration of AR conditions at each location with 99%, 75%, and 50% confidence. A high confidence forecast such as this for a long duration atmospheric river can provide water managers with the information needed to make important water management decisions.
The Atmospheric River Landfall Tool helps the water manager determine the necessary dam releases by providing important information about atmospheric river landfall, location, probability, and duration. What's nice about this tool is that all of this information is provided in one convenient graphic.
Another valuable tool to assist in planning for potential impacts from atmospheric rivers is the AR scale forecasts. Developed by a team led by Marty Ralph, the director of CW3E, and published in 2019, the AR scale helps to distinguish between ARs likely to be mostly beneficial and ones that are mostly hazardous. The scale varies from an AR1 ranking for weak ARs with primarily beneficial impacts to an AR5 for the most extreme ARs with primarily hazardous impacts. While all ARs can bring beneficial precipitation, the chance of hazardous impacts increases with each AR rank. Rankings of an AR on the AR scale are determined at specific locations based on the expected duration of AR conditions and integrated vapor transport, IVT. For example, at a given location, an AR with water vapor transport of IVT between 1,000 and 1,250 units would be considered an extreme AR in terms of its intensity, but it could rank differently depending on the duration. At that intensity, an AR that lasted less than 24 hours would be ranked as an AR3. One that lasted over 48 hours would be an AR5. An AR5 ranking indicates strong water vapor transport. In other words, strong winds and very moist air combined with long duration. Potential flood damages increase exponentially with each step in the AR rank, ranging from hundreds of thousands of dollars for AR1 or 2 to hundreds of millions on average for AR5s. About 25% of AR5s result in over $1 billion in flood damages. The larger damages occur when the AR hits an area where the ground is already saturated, rivers or reservoirs are full, and the area is heavily populated or has vulnerable infrastructure. Here, we see the 7-day AR scale forecast beginning February 12, 2019. AR conditions were expected in all coastal areas of California, with magnitudes ranging from AR1 near the Oregon border to AR4 near San Francisco and San Diego. At this point in time, water managers and reservoir operators inland from the expected AR3 and AR4 landfalls were preparing for hazards from excessive precipitation, such as flooding and landslides.
The Atmospheric River Program is a set of scientific and technological activities to improve our understanding of atmospheric rivers, our observations of them, and our predictions of them, and to develop tools to use that information in water management and hazard mitigation.
Forecast-Informed Reservoir Operations, or FIRO, provides a way for water managers to better plan for the spectrum of AR benefits to AR hazards and to make the water supply more resilient. FIRO gives water managers and reservoir operators actionable information that is more dynamic than the traditional rule curves because it is based on real-time forecasts. This makes it possible to retain as much water as possible in reservoirs without sacrificing flood protection.
The Army Corps of Engineers is now opening up to the idea of using forecasts in reservoir operations. We're exploring that through the program called Forecast-Informed Reservoir Operations, FIRO.
FIRO is a relatively new water management strategy that helps us make impactful decisions regarding storage or release from reservoirs in order to mitigate potential water shortages while reducing flood hazards.
The use of FIRO demonstrates how forecasts can give water managers the confidence needed to make informed decisions around water storage or release.
The benefits of FIRO were really shown in the water year 2020, when we were able to store 20% more water than we would have not using FIRO, despite the year experiencing the third driest or the third least amount of precipitation on record. Another way in which FIRO serves as an adaptation strategy is that water can be released from the reservoir in advance of large atmospheric river events, thus creating more room in the reservoir to provide additional flood risk management capabilities.
As we advance our understanding of atmospheric rivers, we can better optimize our water management strategies while mitigating risk.
Climate science is indicating that we should expect longer dry periods in climates like the west coast of the U.S., especially California. And those dry periods will be punctuated by bigger AR storms.
The AR Landfall Tool, AR Scale Forecasts, and FIRO can help water resources managers balance the competing but essential priorities of maintaining critical water supplies while also minimizing the dangers from extreme precipitation events, now and in a future climate.